Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we're going to talk about the 7 quality tools. I'm actually only going to use 6 of them in this little example, but the 7th one could be in there as well. We'll talk about that in a second. But we're gonna take a look at the 7 quality tools and how you can just use them in the most powerful way to get your process capability exactly where you want it to be. And this is how the 7 quality tools should be used. So we're going to suggest that we have a problem. We have a process capability. We have a CPK. We have a CPK that's not right. Yeah, so we're making defects. By the way, the quality tool that we might use to get there, of the 7, we might have decided to use the Pareto, and that this is our biggest problem. So that's the 7th tool that I'm not going to use in this little example. But let me show you now the 7 quality tools in action. Okay, let's start. First thing I'm going to do, I'm going to take some data from the process, at least 50 data points. Okay, at least 50 data points. And I'm going to start quality tool number 1. I'm going to do a run chart. I want to see if there's any trends or movement, anything that's wild about my process. What's the data telling me? And by the way, if you want to make more money than any other tool, get yourself a piece of paper and plot a graph, because that's the fastest way to make cash in your business. So we're going to take a look. There's a little example here. Look, we're going to take a look at the data. I'm going to just put a run chart in there, and you can see that the process is just bouncing around like a random number generator, but the center of the process is not moving. So there's a nice center of the process. The process is very stable in that sense. So there's the run chart. So run chart. Then the next tool I'm going to use, well, we're going to use the histogram. So now, quality tool number 2, we're going to use the histogram. Now what I want to see if there are any other patterns in the data apart from a normal distribution, which should be there, by the way. A normal distribution is a good sign of a process behaving in a controlled way, not chaotically. So we're gonna run the histogram. So I'm going to take the same data set, look, and I'm going to generate a histogram. Now the software I'm using in this case, I'm using Cpk Improvement, and here's the histogram. Look, it's a nice normal distribution. There's a few data points out to the left there, a few flyers, but apart from that, a nice normal distribution. Why did I draw that? Well, I wanted to know that the normal distribution was there for the next tool I'm going to use, because the next tool is the CPK diagram. So we've gone run chart, histogram, CPK. Now what's this going to do? Well, this predicts the true defect rate. It predicts the defect rate. It's not an observed defect rate. So here we go, look, I'm going to generate a CPK for that data set, and you can see the defect rate, 44,000 defects in a million. That's a prediction. It's not an observed value. And because I know that the normal distribution is strong in the data, because I looked at it in the histogram, I know that prediction is going to be very good. Okay, so we've got run chart, histogram, CPK. Now then, what's the CPK telling me? Well, it's telling me I have too much variability. I have rejects hanging out the ends. So I've got this shape where I've got data hanging out the ends, and what I need to do I need to reduce the variability, push that distribution in and get rid of my defect rate. Okay, now which tool am I going to use for this? Well, now we're going to go flow diagram. To help me go through every step of the process. Cause and effect diagram. What's the cause and effect diagram going to find me? Well, what I'm going to do is, of course, I'm going to identify all the input variables. And I'm going to reduce the variability. I'm going to control as much of that variability as I can. As I do that, I'm going to squeeze my Cpk in. Okay, so now what I do, I improve the process. And I get rid of my defect rate. Okay, so we've gone 1, 2, 3, 4, 5. There's the 6th one up there. Now the 7th quality tool, statistical process control, SPC. Because once I've got the control plan, now I can add an SPC chart. Control limits, by the way, these are control limits. They are not specification limits, most important. Now that I've got a control chart and a control plan to work to, so I've got the process here. So when I get an out of control limit, what do? I audit the control plan. It's very simple. So what you've done is you've gone 7 quality tools. You've got the process under control. You've locked the controlling with SPC. You've created a control plan when you did the cause and effect diagram. By the way, you should have done all of this anyway at new product introduction. What you're doing here, by the way, is tidying up a mess that you created because you implemented a new product in a half-arsed way. But if you'd have done an FMEA properly in the first place, the FMEA would have generated the control plan. You wouldn't be doing this project. But anyway, we've used the 7 quality tools in order. We've got the SPC linked to the control plan. We get an out of control point on the SPC chart. What do? We simply audit the controls. And when we find the one that's no longer correct, we correct it. In other words, we put it back to standard. We don't adjust the process. That's not allowed. Yeah, SPC is not permission to fiddle about with settings. What we're going to do, we're going to find out the control signal. We're going to audit the controls. The one that's gone wrong, we will correct it. We'll put it back to standard. And there is the 7 quality tools. And if you do that, your operators will be able to sit back, drink tea, read the paper, and count the cash. If you'd like to know more about how to use the 7 quality tools correctly, please buy my book. It's called Drink Tea and Read the Paper, and you can learn how to use the 7 quality tools to pretty much fix any technical problem in your company and make piles and piles of cash.